In the accelerating world of digital finance, the term proof of work, POW, emerges as a cornerstone for understanding how cryptocurrencies like Bitcoin achieve security and consensus. Imagine a vast, digital ledger, maintained not by a single authority, but by thousands of computers, known as nodes, across the globe. Each node records every transaction, and it is paramount that all agree on the same history. How is this consensus reached in a decentralized manner? This is where proof of work plays its crucial role. At its essence, proof of work is a mechanism that requires participants, called miners, to solve complex mathematical puzzles in order to validate and add new transactions to the blockchain. The puzzle itself, though computationally intensive, does not serve any purpose beyond proving that the miner expended a substantial amount of energy and computational resources. This process deters malicious actors because attempting to forge transactions would require an impractical amount of computing power and electricity. Consider a real-world analogy. Imagine a lottery where each ticket requires contestants to solve a difficult riddle. The first to solve it earns the right to write the next entry in the public ledger and receives a reward, in Bitcoin's case, a predefined number of Bitcoins. All other contestants must verify the solution before the entry becomes official. This fair competition ensures that everyone follows the rules and maintains the integrity of the system. This process is repeated every few minutes. Miners compete to solve a new puzzle, and the winner is allowed to update the blockchain with the latest transactions. These confirmed transactions become part of a permanent, tamper-proof chain, hence the term blockchain. If anyone attempts to cheat by submitting false transactions, the consensus mechanism will reject it unless the vast majority of computational power agrees. This makes Bitcoin and similar cryptocurrencies remarkably resistant to fraud and double spending. But there is more beneath the surface. The core secret of proof of work is its resource requirement. Each puzzle solution, known as a hash, is deliberately challenging, demanding enormous computational effort. This expense underpins the system's security. As a result, malicious actors must outpace not just one miner but the combined might of the entire network to subvert the blockchain, an almost impossible feat. The real-world applications of proof of work stretch beyond Bitcoin. Other cryptocurrencies, such as Litecoin, use similar mechanisms. Beyond cryptocurrencies, proof of work concepts inspire innovations in cybersecurity, distributed computing, and even securing voting systems. The removal of intermediaries opens paths toward financial freedom and democratization, one reason blockchain is hailed as the future of money. Yet, proof of work is not without drawbacks. Its vast energy consumption has prompted environmental debates and led some networks to experiment with alternatives like proof of stake. Nevertheless, proof of work remains the gold standard for blockchain security, demonstrating how technology can shape trust in a trustless environment. In summary, proof of work transforms abstract computational effort into tangible security, building the backbone of blockchain technology. By participating, mining, and verifying, individuals worldwide become joint custodians of a new financial order, decentralized, transparent, and secure. As the future of finance unfolds, understanding proof of work opens doors to comprehending not only cryptocurrencies, but also the potential of a reimagined global economy.